We yesterday looked at these two sections, which were about the unique situations. Today we're going to look at systems of inequalities, and this is putting a ton of things that you know together. Ryan, do you have a question? So we know things about systems, which is this whole unit, and you know things about inequalities. We're going to put them together. The goal by the end of today is that you know how to graph two inequalities in 2 dimensions. Okay? So that's the goal that we get to. A lot of you have already noticed that there's not very many notes because I think it's much easier to show you than to put a lot of writing. So the worksheet that I handed out is kind of your notes. So when it's talking about see the practice sheet, this is what I'm referring to, and we're going to do as much of this together as you want. We will have time to do it all together. Fifth hour decided that they understood it well enough. They did, I think, 3 on their own. So, but we'll see. Okay, so some things to remember about inequalities. Remember that different from equations, inequalities let your variable serve as multiple values. Okay, so here we have x is less than 5. All of you in here could give me a different value of x, right? And they would all be right. Drake, can you give me a value of x? 2. Perfect. Jared. Is 5 less than 5? 4. Yes. Rachel? 0. Yes. Do they have to be whole numbers or integers? No? Can anybody give me a non-integer? 4.999. Yes. Yes. Very good. Very good. Ryan, do you have another? Perfect. Okay. So we know that's what inequalities show us. But can we write all of those? No. We can show all of our solutions with a graph, if you remember this from first semester. There's a way to designate if 5 is a solution or not. How do we designate or show that 5 is a solution or not? Lars? Okay. And this, good. This one is just less than, so it's an open circle showing that 5 is not a solution. And then how do I show like all of the numbers that you gave me, Sarah? Good. We shade it, and we make sure we shade the arrow to show we want to continue in that way. So like I said before, to graph an inequality in 2 dimensions, we're going to do this, but with a line on the xy coordinate plane. And then to apply it to systems, we're going to do 2 of those in 2 dimensions. Okay? So these might be helpful things to refer to as far as what they are written out, but this will definitely probably be more help. Okay? So we're going to look at this, and I want you to be on just the graphing linear inequalities. So this is our first transition. We're just doing 1, but we are now in 2 dimensions, xy dimension, okay? So we want to first look at this in terms of the line that's there. So I set it equal just to represent the line. So we're on the one with the 6 graphs. Because we have to graph that first, okay? Just like you said, we can show if the solution or if the value is part of the solution or not by a solid dot or an open dot. Same thing here. We can show, but with a solid line or a dashed line. Okay, so that's the same representation as an open or closed dot in 1 dimensions, whether it's part of the solution or not. Okay? So we are going to first graph this line. It's the same thing as this, right? It's just the equation with a solid line. So this is just reviewing graphing. So our intercept's at 4. My slope is -3/1. So down 3, right 1. Down 3, right 1. So that's the solutions that make this equation true is everything on my line. But we want the solutions that make the inequality true. we're always going to shade where y is. Okay, we're always going to shade where y is. And I want y to be greater than the line I just graphed. I want the y's to be greater than the line I just graphed. Okay, and some of you will find different ways to figure out which side to graph, but right now looking at this, which side do you think would be greater, above, more? Okay, and we're not talking about area necessarily, but location. Sarah? To the right of the line. Okay? I kind of look at the y values since we're talking about the y. The y values here are 6 and 5. They are greater than they are here, right? So I want the y values that are greater than the line. So we're going to shade all of this. And of course it will go on forever and ever and ever. But what I just shaded, what does that represent? All that I just shaded, what is that telling us, Lars? All of this can be x and y for this. Very good. Any of these points, okay? So if we chose, let's choose 2, 2, okay? We shaded it saying, yes, this is a solution. So if I plug that back into my inequality, -6 plus 4 is 2 greater than or equal to -2? Yeah, it's a solution, okay? And we talk about like the true side and the false side. Like these would all make it true. All of these would be false. I tend to always just check the origin rather than picking a point because the origin is so much faster to plug in. So if I were to plug in the origin, what should my inequality show me? Would it be true if I plugged in the origin? It should show a false statement, right? So I'm just going to show you what I mean. I plug in 0, and then 3 times 0 is just 0. So that's why I'm saying plugging in the origin is so fast. Is this true? No. This is false, which means it should be unshaded. Okay? So that's how I usually just do a really quick check. This was true, and it was on the shaded side. Okay. So those are just ways you can check, hopefully understanding what's solutions and what's not solution. Okay, shall we try number 2? Is it going to be a solid or a dashed line? Solid. Okay. Start at -5. How am I going to progress with my slope, sir? Perfect. Again, all of these points on your line are solutions for the equation, but we're looking at the inequality. And this again says y is less than the line. So where do you think y is less than the line, Ryan? Over here? You think the y values are less here? This side, very good. I think so. You will find a way that makes sense to you. You can always look at the y values. You know, the y values down here are less, and that's what we want. I remember my teacher using like the idea of a ball. If you could drop the ball and it would hit your line, that's above. You would drop the ball on the other side and it would like fall forever and not hit your line, that's below or less than. Again, I think you'll find, by the time we're done, you'll find how you can make sense of it. Okay, let's try 3. We already said this is going to be dashed, right? Because the line is not part of the solution. So we'll start at -5. Negative x is the slope of, perfect. 1. So again, that is representing the same thing as an open circle did. Okay. So if you plugged in any point on this line, it would not come out true because it would be the equals not the less or the greater than part. Okay, and this is saying y is greater than the line. Y is greater than the line. So where do you think y is greater than? Yeah. Okay. If I checked the origin, should the origin be true or false? True. So really quick, is 0 greater than -5? Yes, it's true. We didn't check up here, but should the origin be true or false? Should be false. So 0 is less than or equal to -5. Is 0 less than -5? No. Which is false. And that's why it's not shaded. Okay? Anybody remember how to graph y equals equations? You got 50-50 shot, right? Is it this way or this way? This way, right? It's, yes, opposite the way of the axis. And we're at -4. Solid or dashed? Where should we shade? Above it? As y is greater. So what should the origin tell us? Origin should be true, right? So if you plug in, well, we only can plug in for y. Is 0 greater than -4? Yes. Good. All right, anybody want to tell me how to do number 5? Anybody want to tell me how to do it? Sarah, go for it. Perfect. Good. Perfect. Dash line because it's just greater than. Right. Yep. Correct, I should say. Yes, this way. Because again, though, that's where our y values are larger. If we checked the origin, should the origin tell us true or false? True. 0 is greater than -5? Yes. Okay. Do number 6. I'll do it quick and then you can check with me, but try one on your own. And instead of going up 7 and right 4 and you're off your graph, what's the other option? Very good. Will the origin be true or false here? Should be false. 0 is greater than 2? That's false. Yes, very good. Okay, so here was the first transition from graphing inequalities in 1 dimension to 2 dimensions. How do you feel about that? Okay, now we're going to apply that to doing 2 inequalities on 1 graph, and we want the shared solutions, right? Because a system is the solutions that work for both. Okay, so my lines are both going to be solid or dashed? Solid, okay. First one at -2, and then our -1, 1. This is y is less than. So is it more like the left corner or the upper right? Yep. Okay, and I would say don't shade this so heavily that you can't see. When I'm doing solutions, I tend to try to just draw some lines. And you can shade it lightly, but you'll see after we get the next one done what we're looking for, so don't shade too dark that it's hard to see your second set. Alright, then the second one, we start at 2. Down 5. Right one. And am I going to shade which way? So it's kind of hard because it's not so like up and down. But again, look at the y values. What side possesses the higher y values? Because I'm looking for greater than. Jared? The right, yep. So when we did systems of equations, we were looking for this point, right? Because that was the point that was shared. But we're doing inequalities. What do you think that we're looking for? Sarah? Right, the part that's shaded 2 times. So to make sure that I know your answer, just make that really obvious, okay? Some people like to get fancy and use 2 different colored pens. That's great if you're confident that, because it's hard to erase it. It gets to be a mess if you have to erase. Or highlighters, because then if you use like a blue and a yellow, and then you see the green, and that's your answer. So feel free. Okay. Let's do one more together, and then I'll leave the last 2 for you guys to do. Okay. With the amount of time we have left. So, are my lines gonna be solid or dashed in number 2? Dashed. Okay. So starting at -2, and we have that same slope. Did I do that wrong? Okay, it's the same. Oh, it's the same exact equation as that. Okay, it's dashed, and it's y is greater. So which way am I going to shade for y is greater? Above and to the right? Okay, and then the next one is y is less than. So it's almost vertical, so are we going left or are we going right? Left. And again, then highlight to make it obvious, just by shading darker, where everything was twice. Okay, so now I don't want you to just know how to do it, but what does that heavily shaded area represent, Jared? Okay, that make which things, these both true, right? So these over here make one of them true. These down here make the other one true. These make both of them. What's about this white area? They wouldn't, those points would work for neither of them, right? Okay, so I will let you work on the last 2. When you're done, let's check around with a neighbor or something, okay?